Every system loses energy to its environment. We measure this loss as disorganized thermal waste, noise, or static, a universal thermodynamic tax. The standard engineering response is defensive. We try to block the loss. We build thicker walls and better insulators, treating environmental disorder as a constant threat to be minimized. Observer resonance theory offers an alternative. Instead of attempting to insulate against thermodynamic noise, we can treat the ambient disorder as raw material for structural growth. We are going to walk through the design of a universal coherence valve. By stacking specific design elements, we can force chaos to organize itself. By the end of this tutorial, you will have a repeatable blueprint to convert ambient noise into organized energy across multiple physical and mathematical disciplines. A dipole merely exchanges particles until equilibrium. To build structure, we use a tripole. First, the source captures ambient chaos. Second, the mediator acts as a directional valve, filtering energy along a phase gradient. Finally, the sink traps it, locking into a synchronized wave. Without a mediator, a system thermalizes and remains stagnant. By using the mediator to bridge the source and the sink, you create an engine that actively generates coherence. Let's map this tripole blueprint onto distinct physical environments. We will start with acoustics. In this schematic, our entropy source is the thermal fluctuation of a fluid. The mediator is the flask, a prime ratio acoustic cavity driven at 26 kHz. This geometry suppresses wave degeneracy, forcing the acoustic oscillations to align. The coherent sink here is sonoluminescence. The cavity's geometry forces ambient acoustic noise to concentrate into a single bubble. When that bubble collapses, it converts sound into picosecond bursts of light. We can apply this architecture to the scale of quantum electrodynamics. In this realm, the source consists of zero-point fluctuations in the quantum vacuum. This topological diagram shows our electromagnetic mediator, a squid array on a coplanar waveguide. Modulating the array at twice the cavity's resonant frequency acts as a non-reciprocal filter, creating the dynamical Casimir effect, converting random fluctuations into entangled microwave photon pairs. Despite the massive difference in scale between sound waves and the quantum vacuum, the underlying engine, the source, mediator, and sink, performs the same structural work. Now, let's apply the blueprint to the dynamics of liquid water and cellular biology. In biological systems, the pool of disorganized thermal bulk water surrounding our cells serves as the entropy source. The aqueous mediator is the geometry of the water molecule. Its 104.5-degree bond angle forces molecules into pentagonal rings. This geometric frustration prevents freezing or total disorder, condensing into a coherence domain, an exclusion zone with a stable negative potential of 100 millivolts. Biological systems utilize this structured water to bridge chemical gradients. Here, the gradients serve as the source, while chiral biopolymers like DNA act as the mediator. The biological sink generates room temperature charge transport. DNA uses a chiral hydration spine to channel protons and electrons, protecting the signal from thermal decay. This sequence, from bond angles to structured hydration shells to charge transport, enables the energy flow required for biological metabolism. Life is a literal geometric exploitation of this tripole valve. We can abstract this architecture from physical matter and apply it to the mathematical realm of data and logic. In a computational model, the entropy source is a field of random, disorganized data. Our computational mediator calculates shared prime factors between data indices. By following this prime factor hierarchy, the mediator filters the noise and identifies common harmonics, forcing the scattered data points to organize into stable semantic attractors, our computational sink. The tripole architecture remains consistent regardless of the medium. Whether we use superconducting circuits, liquid water molecules, or prime-based algorithms, the rules of organization do not change. You now possess a complete map for building an active coherence valve. By moving beyond the dipole model, you can design systems that feed on their surrounding environment. We have seen this valve govern the ultraviolet light of collapsing bubbles, the microwave photon pairs of the quantum vacuum, and charge transport within DNA. Apply this source-mediator-sink architecture to your own engineering, coding, or physics projects. Look for the noise in your system and build the boundary required to channel it. When you shift your design focus toward the mediator, you stop fighting the loss of energy. You turn the thermodynamic waste of the universe into an engine for creation.